title of my talk today actually changed. It was sexed up as well, like Yuti's. My title I've got here is Remyelination and Multiple Sclerosis. We've heard a little bit about myelin, we've heard a little bit about myelination and remyelination today. I'm just going to really focus on that now and tell you exactly what those words mean. So this is the structure of my talk. First I'll say what is remyelination, and to do that I'll have to talk about myelin a little bit and explain what that is. Why is it important in MS? And thirdly, what research are we actually doing to try and address this issue? So basically, what is remyelination? Well, to explain what remyelination is, I first have to explain what myelin is. You've heard about myelin. I'm sure all of you have an idea what it is. Very simply, it is like the the insulation around an electrical wire, as we can see in this picture here. It enables the signals that travel down the nerves or the electrical wires to travel further, to travel faster, and it also prevents crossover of signals between the wires. So it prevents the signal becoming confused. This cartoon at the bottom here is similar to ones we've seen before. This blue cell here with all of these processes is a nerve cell body, and it has a long snaking axon, which is a nerve process which runs to wherever the signal needs to go. Wrapped around this long process are these yellow blobs here called myelin. I always think on these pictures they look like sausages, but there we go. Even more so actually on the next slide. In order to talk successfully about myelination, you've heard this word before. Actually, sorry, I've got to say, red words basically mean big words. It's a big word alert. Oligodendrocyte's a pretty big word. It's pretty hard to say when you first start saying it. It's very simple. Basically, it's just a cell in your brain which makes myelin. It makes the myelin wrapping around the nerve fibre. You can see these represented by these blobs here. They have these processes which extend out towards the nerve fibre and then will wrap around the nerve fibre, and I'll show you exactly how that happens in a second. Myelination starts before birth, just before birth in humans, and probably isn't finished in the brain until around 10 years old, 12 years old, so you can see even in young life we are still making myelin. One oligodendrocyte myelinates more than one nerve fibre, as you can see here. So this fella here is put out a process to this nerve fibre and this nerve fibre. Equally, one nerve fibre is myelinated non-continuously, as you can see, by multiple oligodendrocytes. And as Sarah was saying a minute ago, that leads to the formation of these gaps in between the myelin, which are called nodes of Ranvier. Ranvier was the guy who named them, and nodes, who knows why he called them nodes, but gaps would have been better in my mind. There we go. And yeah, so these nodes of Ranvier are very important for propagation of the nerve signal, as Sarah said. I'll talk about that a bit more in a second as well. An interesting fact I came across while I was doing some extra research of this, apparently there are 180,000 kilometres worth of myelinated nerves in the human brain. Do you think that's true? That came off the internet. But so that would stretch around the Earth more than 4 times. So there you go. That's a fascinating fact.